So in our previous class, we looked at two important concept and terminology, which is limiting reactant, excess reactant, and also extent of reaction. And we did some examples on limiting reactant, and also example number 3 here on extent of reaction. So based on this one, we have found that our limiting reactant, if we are using the equation for extent of reaction, is A. So today we're going to continue to look at the next example, which is example number 4. So in this example, the question is saying that if you have a feed of 10 gram of nitrogen gas and 10 gram of hydrogen gas, you feed it into a reactor and you'll get a product. So we want to know for this chemical reaction, what is the limiting reactant? Okay, what is our limiting reactant and what is our excess reactant? And also we want to find what is the maximum number of grams of NH3. So NH3 here is our product. When you react nitrogen with hydrogen, you will get NH3. So we want to find how much is our NH3 produced if we have 10 gram of nitrogen and 10 gram of hydrogen. So first of all, since it is our chemical reaction, so we write a chemical reaction. We have N2 plus H2 and we'll get NH3. So the first thing we need to do is that we have to see whether the equation is balanced or not. So on the left hand side, we have 2 nitrogen. So I can put here 2. Now on the left hand side, I have 2 hydrogen, but here I have 2 times 3 is 6 hydrogen. So I can put here 3 hydrogen. So now the equation is balanced. So if you were to draw a flow chart, let's say this is your reactor R. You have on one side 10 gram of nitrogen, right? 10 gram of N2, and you are adding it with 10 gram of H2. And you are producing some amount of NH3. So if we look at here, we know that the mass is always conserved. So 10 gram plus 10 gram, definitely you'll get 20 gram of NH3, right? So definitely you'll get 20 gram of NH3. If you are reacting, everything is reacted, okay? Meaning that all of your nitrogen and all of your hydrogen is reacted. But in our case, we cannot say that here it is 20 gram of NH3 because we know that we have our excess reactant and also our limiting reactant. So we cannot put here 20 gram of NH3. We can put here 20 gram of total, meaning that there might be some N2 or some H2 left in our system. So we need to know which one is our excess reactant, which one is our limiting reactant. So if let's say N2 is your excess reactant, so the system will have NH3 and N2 that is unreacted. Or if let's say you say that your limiting reactant is N2 and then your excess reactant is H2, then you will have unreacted hydrogen here. And this total here, NH3 plus H2 will equal to 20 gram. Okay, because we say that the mass must be conserved. Input must always equal to output. Okay, so you have to understand the concept here. So now we are not worried about that yet. We are not worried about how much mass is, total mass is coming out. Now we want to find our limiting reactant. So the first step is that since we are given mass of nitrogen and mass of hydrogen, we have to change both of these into mole of nitrogen and mole of hydrogen. Okay, so first of all, let's say we do mole of N2. is equal to, so we know that the molecular weight, I just put it here, molecular weight of N2 is equal to 28 gram per mole. The molecular weight of hydrogen gas is equal to 2 gram per mole. So we know the molecular weight. So we know that we have here 10 gram of N2. So we divide with our 28 gram per mole molecular weight and we will get a mole value of 0.357 mole. The same thing we do for mole of hydrogen. We have 10 gram of hydrogen and we know that our molecular weight for hydrogen is 2 gram per mole. So we'll get here 5 mole. Okay, so now we have gotten the value of mole of nitrogen and mole of hydrogen. We can start by doing to find our limiting reactant and excess reactant. So I can also write here on my flowchart 0.357 mole and 5 mole here. Okay, so this is equivalent. Now we have two options, whether we use the stoichiometric ratio to find our limiting reactant, or we can also use extent of reaction. So let's say I want to use the stoichiometric ratio first. So I know that 1 mole of N2 will react with 3 mole of H2, right? Based on my stoichiometric coefficient here. This is 1 here, this is 3 here. So in order for me to have completely react 1 mole of nitrogen, I will need 3 mole of hydrogen. But in my system, I only have 0.357 mole of N2. So in order for me to react all this mole, I need 3 times this mole. Why? Because for 1 mole, I need 3 mole of hydrogen. So 0.357 times 3, I will get around 1.071 mole of hydrogen. Okay, so based on this is the required amount of hydrogen I need to completely react with the nitrogen, with all the amount of nitrogen. But I know that from this here, I can see that the amount of mole of hydrogen I have in the system is 5, meaning that I have more than the required amount to react with all the nitrogen. So from this relationship, I can say that this one is my limiting reactant and this one is my excess reactant. Okay, so I have answered for the part A. So this is the first way to solve this one. Let's say if you want to use extent of reaction method, right? So we know that for extent of reaction, we know that the formula for extent of reaction is extent of reaction is equal to the final mole in the system minus the initial mole in the system divided by the stoichiometric coefficient. So if I want to find the extent of reaction for nitrogen, write it N is equal to, so if we are using the extent of reaction, we say that we are trying to use the maximum amount of nitrogen, meaning that I'm using all of my nitrogen that is available. So meaning that if I'm using all, then my final mole of nitrogen in the system must be 0 minus the initial mole is 0.357 and I divide with my stoichiometric coefficient here, which is 1. Okay, so 1. But I know that since this is my reactant which is being consumed, so I put here a negative value. So I can get here the value is 0.357, and the unit here is mole. So if I do the same thing for my hydrogen, same thing, I use all my hydrogen, so final will be 0 minus my initial mole is 5 mole here, and then I divided everything with my stoichiometric coefficient, which is -3. So I will get here my extent of reaction. The maximum extent of reaction if I'm using hydrogen is 1.667 mole. So based on this one also, I can see that this has the smaller value, so meaning that nitrogen is my limiting reactant and my hydrogen gas is my excess reactant. Okay, so you can use whichever method you feel comfortable using. At the end of the day, you'll get the same answer. So that is for question A. For question B is asking us how much of NH3 can be produced, right? So now we know that our limiting reactant is our N2. So we know that if you look at the stoichiometric coefficient and the stoichiometric ratio, we know that 1 mole of N2 will produce 2 mole of NH3, right? Based on our reaction here, 1 mole of N2 will produce 2 mole of NH3. So now I have 0.357 mole of N2. So I will produce double the amount of N2 that I have, which is going to be 0.3572. I will get a certain amount, but then I also want to find the value of gram. So the question is asking us what amount of gram I will produce. So I can just straight away do 2 mole of NH3 times, okay, times 0.357 mole of N2, right? And then I can divide here with 1 mole of N2. So I can do cancellation, and I know that the molecular weight of NH3 will be 17. Okay, so I put here 17 gram per mole. So I can do unit cancellation here, mole of this one, mole of this one, mole of NH3, and this is mole of NH3. That's all this one. And if I do everything, I times everything, I will get the amount of NH3 is 12.14 gram. Okay, so this is my final answer. Now if you look at here, remember we said that I have 10 gram coming in, 10 gram coming in. So now I have found that this NH3 is 12.14 gram. So by right, whatever is left around 8.86, right? So 8.86 gram must be the unreacted hydrogen. So please go back and try to check whether you can get 20 gram here or not. Because by right, if you are using all the correct calculation, you should be able to get this value again.